This conference will now be recorded.
So I request
Hello.
all the participants. I request all the participants to mute. I will give you just introduction about our today's speaker. He is going to take the first session in biodiesel production process and strategies to use in biodiesel in CI engines. So about sir, Dr. R. Balasubramanian is presently working as assistant professor in automobile engineering department at A.D. Patel Institute of Technology, New Vallabh, Vidyanagar. He has received the BE degree in automobile engineering and MTech degree in thermal engineering from Indian Institute of Technology, Roorkee, India. Later he pursued the PhD degree from Center for Energy Studies, Indian Institute of Technology. His areas of research includes internal combustion engines, alternate fuels for compression ignition engines, and renewable energy. So we welcome you, sir, for this FAP. And now I hand over this session to Dr. R. Balasubramanian, sir. Please, sir.
Okay.
I request once
Thank
again
you.
all the participants to mute, please.
In case you have an interruption, just call me so that I can know that what is the current status. Okay.
Yes, sir. Sure.
Good morning to you all. After some technical hitch, I am starting. I'm very sorry for that. My internet connection is not that much quick in the laptop, so I'm just coming to the mobile version of the presentation. So today's topic is biodiesel production process and strategy to use biodiesel in CI. So what I'm going to cover is initially the production process and then the strategy. Strategies means most of I have gone through the topic. Most of the speakers they are going to give on performance, emission, and combustion. So I'm not going to touch upon that. Just I'm going to touch upon how we are going to use biodiesel after the production process explanation. I am going to tell what are all the ways that we can use biodiesel in CI engine.
Oh, sir, there is a
yeah, please.
there is a break in your voice, sir. Please, voice breaking is
There is a
there.
crack. Okay, so now it is clear. Now it is clear.
Yeah, fine,
Hello.
sir, fine. Fine, sir, continue.
Can I proceed?
Yeah, you can proceed, sir.
Okay. So the topic of the day is biodiesel production.
Sir, you can unmute, sir. You can unmute and speak, sir. You can unmute, please. Yes, sir. Now we can speak.
Okay. It is okay now?
Yes, sir. Now it is okay.
Hello.
It is okay, sir. You can carry.
So, okay, I'll proceed. So the biodiesel production process to start with, there are four main production methods. One is the direct use and blending. Second one is the micro emulsion. Third is thermal cracking. Fourth is trans-esterification. So out of which the main focus is given to the last one, which is the trans-esterification process. So in direct use and blending and micro emulsion, so it is the raw vegetable oil which is used. In thermal cracking, it is somewhat near to pyrolysis kind of thing. With oxygen or without oxygen, you're going to have the thermal cracking. In the main focus of today's production process will be on the last one, which is the trans esterification. So we will be giving less stress on the top three and more stress on the trans esterification. So biodiesel production process, continuing with, there are established technique in the process that have been used to produce biodiesel from non-edible oil. Basically, it reduces the viscosity of the oil. So that is what our intention is all about. Out of all these methods, the transesterification is a viable process that has been adopted to reduce the reduction in viscosity. So that is what our main aim is all about. Of the several methods available for producing biodiesel, transesterification of natural oils and fat is currently our method of choice because of the following reason it is coming. The purpose of our process is to lower the viscosity of oil or fat, as already told you. So basically it is a sequential process, sequential reaction which is going to happen. What are all the sequence thing? It is coming in the next slide. The main factors affecting the transesterification, the process, the speed of the process is being affected by the molar ratio of glycerides and alcohol. It is the ratio between these two. The catalyst, reaction temperature, and the time. So the time factor is also playing a major role in this. So free fatty acid and water content in the oil is also one of the factors. So biodiesel as such, you define biodiesel is defined, definition given as it is a trans-esterified triglyceride with methanol. Basically, the triglycerides reacted with methanol. So whatever you are getting is, one is biodiesel, the other one is the glycerol. Methanol is preferred alcohol because for obtaining biodiesel, it is considered cheaper. So going through the equation, methanol is made to react with triglycerides, as already told, to produce methyl ester and glycerol. This methyl ester is known as your biodiesel. And the equation, going through the equation, triglycerides plus methanol gives you methyl ester and glycerin. So there are four basic routes to form a biodiesel. One is the base catalyzed transesterification, direct acid catalyzed transesterification, conversion of oil into fatty acid, and then into biodiesel. So this is a kind of the thermal cracking or pyrolysis kind of thing. And then from that fatty acid, you are getting the biodiesel, third one. Fourth one is non-catalytic transesterification of oil and fat. So basically, we are going to concentrate on the first two. The last two is coming for other purpose also. Apart from the biodiesel production, there are some other purpose with the last two method routes. The first two type have received more attention because of short reaction time and low cost. So the reaction time is around 1 hour to 2 hours, the reaction. Then the settling time, those things is separate. Low cost compared with the third one. So third is the pyrolysis kind of thing, thermal cracking. So compared to that, the two types, first two are more relatively cheaper. Most of the biodiesel produced today is from the catalyst, base catalyst reaction for several reasons. So those are what are all those reasons? Number one is it involves low temperature and pressure. At normal temperature and pressure, this reaction can be possible. It yields high conversion, around 98%, with a minimal side reaction and reaction time. So the yield is more. That is what. Third point is it allows direct conversion from biodiesel into biodiesel with no intermediate compound. So once the raw material is given, and if you mix it and get it react, so final product will be biodiesel. So there is no in between process. That is also one advantage. That is also gives you more yield. And it requires simple construction material. Means only the reactor is needed. The rest of them are simple thing. So what are all the process sequence of process in the base catalyst production? Number one is mixing of alcohol and catalyst. That is one. Second one is the reaction, which is happening in the chamber. I'll show you the picture after 2-3 slides. Then the transesterification reaction takes place, and then the separation of the glycerol and biodiesel, and biodiesel washing in case there is a leftover, some catalyst is left over, or some alcohol is left over, so that are all removed. And finally you are going to get the glycerin, or if it is combined with alcohol, it is glycerol, and final product you get the quality product. So these are all the sequential steps. So in Indian context, we are going to use Jatropha and Pongamia, otherwise known as Karanja seeds. From that you are going to get the oil, and then you are going to process further. So this one is the biodiesel reactor, as shown in the innermost chamber. It's the oil, and the alcohol is poured along with the catalyst. And the outer shell, there is a heating coil which is used to heat, and there is a recycling of alcohol. The vapor is captured and cooled, then it is given. And normally excess alcohol is given to complete the reaction in maximum, for the maximum yield. So this is the biodiesel reactor. And after, once the reaction time is over, after 1 to 2 hours, depending upon the quantity as well as the requirement, it is poured in a chamber or a collection point. And after some time, after settling time, this one is the picture which is showing. In the topmost we have the biodiesel, the bottommost one is the glycerin or the glycerol. So the after sufficient time is given for settling, so you can separate it out. The bottom one you can remove, the glycerin is removed, and what is remaining is the pure biodiesel. Then you can wash it, as we already told, we can wash it with water to remove the excess base or excess things, and then finally you get the biodiesel, pure biodiesel. The flow diagram which is just shown here is the oil seed, and after that processing, you are getting vegetable oil by adding methanol and the catalyst. You are going to neutralize the oil, then the transesterification reaction takes place. You're going to get the fatty acid as glycerin as product, and finally you are going to get the crude biodiesel, and after that you are purifying with water, and then finally you are going to get the methyl ester. So there is a sequence of processes. So here the base catalyst is sodium hydroxide basically, or potassium hydroxide, known as soda or potash. The base catalyst is dissolved in alcohol. That's why the alcohol comes into picture. The catalyst poured in the alcohol, then it is stirred and mixed well, and then the alcohol catalyst mix is then charged into the closed reactor, and the oil or closed reactor, and the oil or fat is added furthermost. Okay. The reaction of the mix is kept in just above the boiling point of the alcohol, which is around 60 to 70 degrees C, to keep up the reaction, and the transesterification reaction takes place. So it is maintained in that temperature so that the complete process is going on very fast. The normal time is 1 to 8 hours. That depends on the nature of the oil and your catalyst, all those things. And the optimal reaction time is about 2 hours. So in normal case, it is 1 to 2 hours is more than sufficient to complete the process. Excess alcohol is normally used to ensure the total conversion of the oil into ester. So complete, so that you get your yield is at the max 98%, 90 plus, 95 plus percent. After the reaction is complete, your final product is glycerin and biodiesel. Here, the glycerin also a product which can be further used in industry. The glycerin phase is much denser, so that it is in the bottom. Then biodiesel, so the two can be gravity separated. You keep it for some time, it will automatically be separated, simply drawn up to the bottom and in the settling vessel. The biodiesel product is sometimes purified with washing gently with warm water. Slightly boiling water is poured, and then it is ultimately washed with warm water to remove the residual catalyst, or if it is soap or any air, soap is there, and then it is sent to the storage. So finally, what you are getting is the pure biodiesel. Hello, my audio is clear? Hello.
Yes, sir. Yes, sir.
Sir, it is clear.
Yes, sir. Clear, sir.
Oh,
It's
I'll
clear, sir.
proceed. Okay. Okay. So, what are the some of the important factors of production of biodiesel to ensure the trouble-free operation after that? So once you are getting the biodiesel, you are going to use that in the engine. So what are all the things to be considered? One is the complete trans-esterification process. If the process is not complete, if some remaining fatty acid or something is there, so the reverse reaction may also take place. The fatty acid may become prominent from the biodiesel. It will become again to the fatty acid. So we should not allow to do that. So in that case, again, in the reversal of the process take place. So you must ensure that complete trans-esterification reaction should take place, and you should remove the glycerin completely, catalyst, alcohol, as well as some free fatty acid. So that's why we are washing it with the hot water to ensure these things are not there. So once you are done this, once you're getting the biodiesel, these parameters are specified through the some standard biodiesel standards. What are all those standards? ASTM D6751. So this is the standard prescribed by the testing authorities. This standard identifies the parameters of pure biodiesel. It is 100% biodiesel. Nothing is blended, but must meet before being used as a fuel, or it is being blended with the petroleum based diesel fuel. So as you can see, the specification, flash point, water content, viscosity, ash, sulfur, and those things are prescribed as per these norms. So normally this is tested in the standard testing lab. We give the biodiesel, they will test it and they will certify whether it is under this ASTM or not. So for our case, the biodiesel is produced with the batch processing, which is the first one. Biodiesel production is with batch processing. So you're some fixed quantity, you are going to use the chamber and then produce biodiesel, and then you are going to remove. So this is for laboratory purpose we are doing. So in our laboratory also we have done this batch processing. So you have a small unit, laboratory scale. We have produced the required biodiesel. It is used maybe within a week. Then the experiment is done. Further, next batch is done. And while doing those experiment, make sure that the raw material comes from similar content. If you purchase in bulk, so that the quality remains almost uniform. If you purchase today and after some time you purchase, so those quantity or quality may differ. So that also, when you test, you know that it is not meeting with your standard. So you make sure that whenever you are purchasing, make it in a bulk, so that for testing purpose, at least you maintain the quality uniform. The second is biodiesel production with the continuous process. So wherein it is fed continuously. Once one batch is over, again the second is poured inside. Not much difference, but it is a continuous process. You make sure that the availability of oil and the other catalyst is available continuously through that process. And the last one is the supercritical process, which is done to cut down the reaction time of the entire transesterification process. So here we use a slightly higher temperature, depending upon the requirement. We use higher temperature as well as high pressure, above atmosphere pressure, as well as higher temperatures are used, so that you make sure that the reaction ends in much faster time. So this is depending upon the requirement. Most of the European countries, they follow this supercritical process to make sure that they will not wait for the process to end. So maybe within hours it will end. The entire process is over. And coming to the benefits of biodiesel, this is already known to the most of the participants. It is renewable, energy efficient, and displaces the diesel. Can be used in most of the diesel equipment with no or only minor modification. Those we will explain that in the next part of our presentation. It can be reduced. It can reduce the global warming gases. This is one of the main main advantage of the biodiesel. The global warming gases is also reduced, apart from your tailpipe emission, and this is non-toxic as well as it's biodegradable. That is from the added advantage. So apart from the biodiesel, I think some of the speakers may repeat this also. There are some additional available biofuels or there. I'm not going to explain, but the process which we are doing, in that the side process is we are getting some other products like bioethanol, methanol, DME. That is also one of the main fuel for CI engine, and biogas or synthetic natural gas, and biohydrogen. So those are all the additional biofuels which some of the other speaker may explain further. The biodiesel is by transesterification process. So far we have explained that. And the green diesel is by pyrolysis or hydrocracking. Biogas is by anaerobic digestion, or you can say thermal cracking or something like that. Biohydrogen, again gasification and steam reforming. And this one is very important, the FT diesel or Fischer-Tropsch diesel. It is by gasification and synthetic synthesis process. The last one is dimethyl ether, again the gasification plus synthesis process. So while doing the transesterification, it's a side part, next process which is happening parallelly, as you can see in the next diagram. So it's a non-edible oil. To extraction, it is coming as straight vegetable oil, and we are going to the transesterification process, and we get biodiesel, which is run on the diesel. In seed cake, which is the remaining of the oil extraction, which is again fed to the pyrolysis process, and you get bio oil and char. And in the bio oil is thermal cracked and then you get the green diesel again, which can be used in the diesel engine. So it is a side process. You are doing one product, and the byproduct, which is the waste, and that can be also used in the production of green diesel. And the last part is the anaerobic digestion, from which you get the biogas, and then it is upgraded to used in a spark ignition engine, which is a separate part. So we are covering the left hand side and the middle part. The right hand side, maybe some other expert will explain. Okay. So the other one is the gasification. So this is the main part. And the sub part is the feedstock gasification. So you get two things. One is the syngas, which contains CO and hydrogen. And from that, you go to the Fischer-Tropsch synthesis. And from that, you get FT diesel. And again, it can be used in diesel engine. Or the other process is, which is given in green color, the methanol synthesis process. And which is by suitable process, you can do DME. There are several processes which is available. And from there, you get the fuel for diesel. So currently the DST as well as IITs, they are working on this fuel, which is the current trend, DME, which is a gas. Basically, it is not a liquid fuel, it's a gas having similar properties to that of LPG. So if you can handle LPG, you can handle DME also. So that can be used as a diesel engine. Maybe afternoon, some of the speaker, they may explain the use of DME in CI engine. And the two other information I wanted to give is the hydro-processed renewable diesel. This is a product which is under research from Indian Institute of Petroleum, Dehradun. They are working on this hydro-processed renewable diesel, which is more or less similar to your biodiesel. They are using a separate process, hydrogen. They are treating it with hydrogen. Of course, not much is known. Maybe you can search it in Science Direct to know further details of this one. And IOCL Faridabad, they are also having a biofuel center. They are also working rigorously on some of the biofuels. Somebody working on biofuels, or they may also interested in getting some information, they can contact this IOCL Faridabad for further details. So this the IIP and IOCL, both are rigorously working on this fuels, biofuels, especially with diesel engine. So the top 5 countries, as you can see, major countries expected with high biodiesel production: US, Canada, EU, India, and Brazil. So these are all the top 5 countries. And the bottom one shows the highest biodiesel producing countries, 2017. So slightly older data. Maybe some changes might be there as of now in the current situation. So that ends the first part of the presentation. If you have any query, I will answer. Otherwise, I'll move further for the strategies to be. Can I move further, or I can wait for some queries? Hello. Hello. Hello.
Carry on, sir.
Hello.
You are audible, sir.
I can.
Sir, you can
continue?
carry
Yes,
on.
sir. Please carry on.
Okay, no problem. So some strategies to use biodiesel in CI engine. So as such, what we have seen is blended with diesel, biodiesel blended with diesel, which is normally known as B20. The second is micro emulsion. The third part is known as B100 or the fully biodiesel, which is normally called as B100. In the first two, B20 and micro emulsions, not much changes are needed. So as such, you can use it in blending with biodiesel as well as in micro emulsion. Normal diesel engine, currently available diesel engine, which can be used. But for biodiesel, 100%. So we need to change some design aspect or some, you can say, एक कागज है वो दे देना. Okay. So with B100, we need to change maybe some of the parameters. So that what are all the changes that we have to make, that I will explain in further slides. Currently, what the biodiesel engines are retrofitted. That means we are using a diesel engine. In that, we are putting the biodiesel as a fuel. So that is known as retrofitted. Currently existing facility, we are just changing the fuel. So if you want to really use 100% biodiesel, so the optimization of the engine is needed to use biodiesel 100%, or even B20 needs some changes. So what are all those changes? With the B20 blending, no or minor modification is needed. So maybe as per the literature, it is reported that the fuel filter may get choked after some time of the prolonged use. So fuel line has to be checked properly, and if it is some plastic or some elastomers are there, so they are corroded or they are their property, they may lose their property. So you need to change that, and you need to change the filters periodically to cope up with the corrosion which is happening because of the biodiesel. So this is with the B20, not much changes, only the maintenance of line and filter which is needed, which is slightly frequent than when you are using the diesel. So problems, generally what are all the problems which are observed when we are using biodiesel? The fuel energy content, of course, the calorific value is slightly lesser, or depending upon the species. So you need a slightly bigger tank to cope up with the mileage. So if you're going for a long term, you may have to add some more fuel. So the tank is slightly want a bigger tank. Higher pour and cloud point of fuel, freezing in cold weather, causing cold weather starting. So this is also reported at high altitude or in low temperature area. This is a problem. The pour point, high pour point as well as cloud point. So this may freeze the fuel, and which may cause the starting trouble in the initial. So there are some provisions for that, how to have the cold starting. We can have some provision for that. And in general, biodiesel has a corrosive nature against copper and brass, and that is also seen. So those who are coming in direct contact with those metals, so it may corrode. So make sure that the fuel line is not containing any copper or brass things, so that this problem can be eliminated. So these are all some minor problems, not some major problem. So what is further needed is to use biodiesel in the normal activities. It's where what we lack currently is it's a national level policy for biodiesel. So currently there is no policy. Only what they say is B20 is allowed. As per the government of India policy, biofuel policy, 20% or less than 20% blending is allowed. No B100 is allowed. and there is no clear-cut policies available. So what we'll go from the bottom to the top. Currently, no data or very less data available with the B100 with the OEMs. So ultimately, the OEMs are one which they are going to give you engine. So you are going to use an engine which is produced by the OEMs. So what they lack is they don't have any data to build an engine or any biodiesel engine. There is no supportive technical data also. So to claim that we need to produce a biodiesel engine. So supportive data and as well as 100% biodiesel data, dono mila ke, we have to get both and then we have to give it to the OEM. And OEM and the policy makers, they should combine those policies and recommend it to MNRE, Ministry of New and Renewable Energy. So once the government is making a national level policy, then only we can get a dedicated biodiesel engine. So that is currently lacking. There is no national level policy because of these reasons as such. So OEM, they are not going to accept anything which is not in the policy. So currently we don't have policy, so we don't have any dedicated work on this biofuel engine. So what is the possible solution? Once you have the policy, a dedicated engine can be designed. What are all the suggestions? Just change some parameters, design as well as operating parameters. So both we need to recommend through some experiments, through some research, we need to recommend. So these are all the final thing that has to be incorporated in that engine. Not much. It is not that you are going to entirely change the design of the engine. It is only slight changes which is easily possible for the OEM to get adopted. Okay, so if at all we are going for a B100 engine, B100 fully run engine, what are all the things we need to consider as an researcher? For utilization of the biodiesel in diesel engine, currently what are the problem we are facing? Power drop, that is because of the less calorific value, and pump not able to supply the required fuel for producing the same amount of power. These two are the reason for the power drop. And the next one is less thermal efficiency, and that is because of the early start of injection, early combustion, less premixed phase, less premixed combustion phase. So that is because we are getting a less thermal efficiency. The third was a higher NOx emission, automatic advance in the injection timing, higher penetration distance, oxygen content, and adiabatic flame temperature is very high. So these are all the reasons for high NOx emission. So we need to address these three problems in order to overcome those problems, and we need to recommend these are all the changes which is needed to run 100% biodiesel. So what are all the next is the existing problem of low thermal efficiency and high NOx emissions should be addressed, as we mentioned in the previous slide. Experimental study is aimed to find a solution. So in IIT Delhi, we have conducted one experiment focusing on these problems. So as you can see, this is the experimental setup having all the engine, data acquisition system, dynamometer controller, exhaust gas analyzer, smoke meter, dynamometer. You have both the fuel flow and the air flow meter. So what we have done is we have taken three parameters as variables. One is the compression ratio, the next is the injection timing, and the next is the EGR, exhaust gas recirculation. So we varied the possible with the current existing data. one step higher and one step lower. In these three cases, we have done the experiments, and the conclusion from those experiments are operate the engine at higher compression ratio. That means with 21.1. Currently, it is 19 jump 1. So 21:1 is the current compression ratio. Higher compression ratio, which is recommended for biofuel. And the injection timing, we need to retard the injection timing. And the EGR, which is recommended, is 15%. So these three are the main conclusion from those experiments. So finally, to use biodiesel with the maximum efficiency and minimum emission in CI engine, it has to be operated at a higher compression ratio with retarded injection timing and 15% exhaust gas recirculation. So currently, those engines which are coming in market, they are fitted with EGR. So only thing is you need to change your injection timing to the retarded side. So once we have changed all these parameters, so we will be able to get a complete biodiesel maximum efficiency with the CI engine. So if you have any questions, I will answer, or you can put the WhatsApp also. And thank you very much. Hello.
Sir,
Yeah.
good morning, sir. Good morning, sir. Sir,
Oh,
can biodiesel be a perfect substitute for a conventional diesel or petrol conventional fuel? Because yesterday one professor told that still biodiesel, all the biodiesel in the research conditions only, implementations and production is not because we have been doing the research for long time. The present status, how we could.
I'm not able to hear your audio. I'll just come to WhatsApp. Can you put the question in WhatsApp so that I can answer? Your voice is breaking. You are saying the biodiesel fuel. Can you give the message so that I can? Now I can come to the normal.
Okay, sir.
Can I come to the normal mode?
Okay, sir. Yes, sir. It's
Madam,
a
you
chat.
can put
chat.
your question in chat box also.
Okay, sir. Okay, sir.
I will come to the chat box. Yeah.
Sir, there is one question: why biodiesel is not commercialized?
Yeah, that is what I told in one of the slides. There is no national policy available with the government. See, unless otherwise it is a policy drafted in the Indian by the government of India, so it cannot be commercialized. Even for one example, I will give. CNG can be used in four-wheeler. Okay, so now people are coming with CNG in two-wheeler. Okay, so in two-wheeler it's a small container, but if you go to the CNG pump and if you want to fill that in two-wheeler, they will not give you, because there is no policy by the government to fill CNG fuel in two-wheeler. So it is not available. Even though it is technically possible, commercially it is not available. So it has to do with the government. The government policy should come so that it can be commercialized fully. But even then, in some of the places it is available. In like a state of where I am living, Gujarat, you can see some of the petrol pump. They give biodiesel. You can get it, but currently they are using it for agriculture purpose, not for running engine or something like that. And here also in some of the agriculture university, they are internally for their own purpose they are producing the hello, can you able to hear me?
Yes, sir.
Yes, sir. Yes.
So in some of the agriculture university, they are producing biodiesel in a bigger plant, biodiesel plant, and they are using it for their internal purpose. Not they are selling commercially. They are using it for their own purpose. It is there, not commercially available. For commercial purpose, we need to change our policy. Government policy should be changed. Then only it is permitted to give commercially. The selling is possible only when it is permitted by the government. Any other? Chat box, I am not able to see. Okay,
There is
there are
another
some.
question, sir. Higher NOx is due to
How
yes, sir.
much?
I can read it, sir. Higher
Uh,
NOx is due to high oxygen content of biodiesel. Is it possible to optimize the oxygen content to control NOx emission?
yeah.
Is it
Why
clear?
naturally? Yeah. You are asking that how much oxygen content is needed so that in the fuel, so that you can reduce the NOx
NOx
in
emission.
the, yeah. So already it is there in the fuel itself containing the oxygen, so you cannot reduce that content. And while you are supplying the air, that also not possible to control the oxygen level. You are going to supply air, you are not going to supply oxygen. So I think we are not able to control. But what we can do is by playing with the operating parameters, or you can optimize those parameters so that you can maintain the P theta peak at the left of the TDC, so that you can reduce the NOx. The peak should not come at the TDC. Peak should be before the TDC, so that your your NOx level will be minimal. So as we have suggested, two things. One is the retardation, uh, injection timing retardation, as well as EGR, 15% EGR. Both these will reduce NOx. You cannot do anything with your oxygen level in the fuel as well as the supply of oxygen. That cannot be controlled. So by playing the operating parameters, you can control the NOx. So that is what suggested in the PPT also. Yeah.
Sir, any query? Yes, any query? Do you want to ask?
I have one question, sir.
Yeah, now I am able to see some of the questions. How to produce biodiesel in large scale, as the raw materials are limited. So, Saurav Rajan Das, he has asked how to produce biodiesel in large scale. So, you can get the information from any of the agriculture university across India. Even in Gujarat, there are some agriculture university. They have the with the help of the government, MNRE and DST, they have the large scale biodiesel plants are available. You can replicate that also, as the raw materials are limited. No, raw material is not limited in this part of the world where I am living in Gujarat and Rajasthan. This Karanja fuel is excess, so there they are converting it into biodiesel. What is the abundant available? What is the abundant available source of biodiesel? However, not researched more. Any vegetable oil, so that abhi jo what is currently going on is, see, now what we are doing is just Jatropha and Karanja. Only we are taking two species only for biodiesel production. But there are some researches going on wherein you put any oil. Yeah, hello.
Sir, Pingomia?
Wherein you put any oil. Hello. Yeah. Pongamia is nothing but Karanja. That is the botanical name. Jatropha and Karanja. Apart from Jatropha and Karanja, you put any non-edible vegetable oil. there are some common methods they are going to devise. So you put any oil, the biodiesel will come in the same quality. So that is the part of the chemical engineering department. It is still research is on, and still in very early stage. Those currently we don't have much production in all the vegetable oil. It is only restricted to some limited non-edible oil. Our government is not making any correct policy for mass use of biodiesel, because the government is not having any concrete policy, because they don't have any data, because the OEMs are not that much interested. Currently, what is the thing going on? OEM, they say you give the technical input, then only we'll suggest the policy makers to devise some policy. So the bottommost line, as I told you in the PPT, the researchers, they should give solid conclusions along with the proof to the OEMs. Then only it is possible to devise. Is there any major drawback in using biodiesel? As such, there is no drawback. It is a proven CI engine fuel, widely used, especially in US and Europe. They are using it in variety of applications, like in agriculture they are using it as a heating fuel. They are using in engine, wherever it is blending is there, they are using it in almost all application. Even off-road application they are using, construction, those thing, off-road application also biodiesel is used. Any other questions? Sir, what is the problem associated when we blend biodiesel with any alcohol? Please suggest, sir, what percent you can blend. So this is actually not recommended. Biodiesel with alcohol is not recommended, but for just burning purpose, you can add some alcohol to form a emulsion. As you know, oil plus alcohol. Biodiesel with alcohol, it is not recommended. Raw vegetable oil with alcohol, you can form an emulsion and then use it. That means you are going to reduce the viscosity of that particular vegetable oil. As you know, vegetable oil having higher viscosity, you can reduce the viscosity just by adding a small quantity of alcohol, and it is emulsion. Emulsion is another topic. I am not an expert in emulsion, but I have heard that by mixing it with mechanical devices, or at high speed, if you mix it, a small amount of alcohol and with a large amount of vegetable oil, it forms an emulsion. That emulsion directly can be used in the engine, but that is not a solution for our problem. Our problem is to use biodiesel fully in engine. That is what our aim. Yeah. Any other question? Yeah, next is coming.
Sir, good morning, sir.
Yeah.
Hello, good morning, sir. This is BL Salvi speaking. Sir, regarding this biodiesel production, how to calculate free fatty acid?
Free fatty acid, see, if you take any oil, there is no calculation as such. You can test it in any of the lab, which is recommended by the government. You can test that, and they will give you the each and every percentage of free fatty acid. It is not one free fatty acid which is available. There are several number of chain which is available. So you can test your vegetable oil of the known source. You can test it in a laboratory. They will give the individual free fatty acid and their percentage by volume. So they will give it to you. That you don't need to worry. Or if you have the better facility in your college, you can test it in your lab itself. How much percentage of each of the free fatty acid is available in your oil. That can be tested, and there is no calculation as such available.
Sir, if we go
If you
above
know
4% of free fatty acid, what will do?
Free
If
fatty
suppose
acid,
when I'm going to calculate free fatty acid, the value reaches above 4.5 or something. So what is the procedure we can do in the trans-esterification process?
So as such, there is no percentage for. So see, what we are going to do is we are going to crack that free fatty acid to make it to the glycerides, triglycerides हो जाता है. Okay. So there is no connection between above 4% or what we can do it. Anyhow, you are going to make it as a fuel from acid or free fatty acid. You are going to make it into triglyceride, and then triglyceride
Yes, sir.
alcohol combining. You are going to
Yes, sir, I understood, sir. But the thing is, after converting of this biodiesel through trans-esterification process, there are two methods we are using. One is trans-esterification process, next one is esterification process. So if esterification process means, what I call, if free fatty acid more than 4 means, we have to go for esterification process, then followed by remaining steps what you explained the biodiesel production.
Oh.
So that's why I'm asking, if above 4% means, should I go for trans-esterification process or directly we have to use for it? Sorry. If above 4% means, should I go for esterification process or directly we have to use trans-esterification process?
Esterification, trans-esterification, both are same. So as such, there is no. I am not an expert in that area. If you have any query on the engine side, you can please. So this is basically
No, this is not
chemical
engine
engineering.
side, only biodiesel production only. This is not engine side, only biodiesel production.
Yeah, that's what I'm saying. I am.
Thank you,
my
sir.
area of.
Thank
Okay,
you,
no
sir.
problem. Okay, yeah. Any still further question? Hello. Hello.
Hello, sir. Hello.
Yeah.
Am I audible, sir?
Yes.
Yes, there is a question. Why biodiesel is corrosive to copper? Because
I
copper
don't
is
know
very
why,
inert.
but it is. It is in the literature. It is noted that when copper and bronze, when exposed to biodiesel for a prolonged time, barabar, if you keep for a longer time, direct contact with the biodiesel for a longer time, then it is corrosive. Okay, if it is for a short duration, that is not a problem. So in our case, in the fuel line or in the injector, till a tank to the injector, in anywhere there should not be any copper or bronze. That is what it is suggested. As such, we don't have any copper or bronze in our fuel line. So it is just for information. It is given. It is corrosive to copper and bronze, because whenever you are using any kind of such material, you should be careful. You should not expose that to biodiesel directly. That is what the point is all about. Why it is corrosive, that is not known. It is reported in the literature, and maybe for some further corrosive study expert can put a light on that. Okay.
Okay, sir. Thank you very much, sir.
Okay, thank you.
Yeah, thank you, sir. I am Dr. P.S. Rao, sir. So thank you very much, Balasubramanian, sir. So for taking a nice session, So now another, yeah, please, sir.
I'm very sorry for the technical hitch which from my side, because I tried it in my laptop. Somehow it has crashed, or some restarting happening all the time, so that I could start only after 15 to 20 minutes. I'm extremely sorry for that. Otherwise, it was a nice session. I'm happy that you called me and I able to present and able to clear some of the doubts of the participant. From my side, it is thank you. And this opportunity was given to me through my friend Dr. Venkat Chintala. I also thank the organizers as well as Dr. Venkat Chintala for this opportunity. Thank you very much.
Thank you, sir. Thank you very much. No issue, sir, because it is a virtual program, so always these technical issues will arise. But anyhow, you have taken very nice session, sir. I hope all the participants are really enjoyed your session. So next session will start at 12 o'clock. Next session will I would like to inform all the participants that next session will start at 12 o'clock and 12 to 1:30. It is also very good session, and I request all please to join in that session also with the same link. The link is common for all 3 sessions today. So we'll be having session at 12 o'clock. That is on photon, something like that, and it's like a third session will be from 3 o'clock to 4:30. So please join at 12 o'clock for the next session. Thank you, sir. Thank you all once again.
Okay. Thank you.
So I will be sending you participants. I am sending you the SARS PDF material, so you can go through the PDF material, and if you have any other doubt, you please let us know so that we will clarify through SAR only. Take care. Thank you, sir.
Yeah, I have given my WhatsApp number. If you have any query, you can put that in WhatsApp so that I can answer for those session also, for those questions also.
Yes, sir. Thank you, sir.
Oh, okay. Thank you very much.
வாங்கடா நான் அதை காட்டுறேன் நம்ம பேசும்போது